Hello everyone, happy to be here. We're going to talk about the GenAI carbon footprint and impact. Lorena, maybe you want to introduce yourself.
Thank you very much. I'm Lorena Nava. I'm a sustainable IT consultant and I work for IJO. IJO is a consulting firm specialized in sustainable IT. So we only do that. It's a lot of things to do. We are experts in carbon footprint. It can be for a service, for an application, or in this case, AI. Also, we work with the strategy and action plans to reduce the impact of IT. Also, we have an offer about sustainable IT procurement. And finally, we have a research center. And for the occasion, I'm in charge of research at IJO. With the research, what we try to do is to be on top of these kind of subjects and try to be a bit on advance to understand what is happening on the world and how can we tackle the new challenges that are out there.
And I'm Damien Juillard. I created this company on behalf of AI. It's a consulting firm dedicated to support the appropriation of AI by the companies, especially when it comes to the procurement field. How to make sure that we purchase the right technology, with the right impact and the right cost. So that's some fields that I'm an expert at. And more globally, we also support everything related to integration when it comes to querying the different models and integrating AI within products. So today we're going to talk about GenAI carbon footprint and impact. Okay. We want to address first the global stakes of this carbon footprint related to GenAI, and we're going to talk right after about how to measure and how to make sure that we know what we consume. What are the key principles? What are the approaches that we can use? Lorena will explain what we have studied together. We will also talk about the environmental impact and what we can use as inductors, what we don't know, what are the uncertainties, and then we will take examples to explain what is the right balance between the research of performance when it comes to GenAI and the carbon footprint impact. And finally, we will list a few resources that are very key when we want to start this carbon calculation journey. Or maybe I can start. Yes. Maybe I can start with the global stake. So this is a table that has been produced by the G9+ think tank in France. This think tank has studied the global impact of digital within the world, and what we can see here is that, of course, it grows. We know that. It's something that we are all aware of. But when we look at the curve, we see that there are two or maybe three scenarios: low case, base case, and worst case scenario. And what is important here is that by 2026, so very, very soon, the difference between the green curve and the red curve corresponds to the global consumption and CO2 consumption of a country like Switzerland. So just because of IT, there is a matter of variation corresponding to a global country. And when I mean country, I'm not talking about the IT consumption of Switzerland. I'm talking about the global consumption of Switzerland. Automotive, building, well, everything that we use all together. So the difference is absolutely huge, and the stake is huge. And what is the trigger between this variation? The main trigger is, unfortunately, AI, which means that this is something that is absolutely important to measure and to understand. One very quick example that has been produced by Google. When you make research on Google search, it does consume 0.3 watt-hour in terms of power. When you do the same on ChatGPT, it consumes 10 times more. So when do we need to go through GenAI to get a response? When do we need to use, let's say, traditional tool like Google? That's a key question. But let's talk first about the measure.
So I'm going to explain, first of all, how we measure IT impact. So if you already know how it works, bear with me, it's going to be quick. But here I'm going to show you the approach we have. So when we evaluate an information system, a website, or an application or an AI services, we try to have a complete perimeter. What is important is to understand everything that matters when calculating the CO2 impact or even environmental impact, and we will start by the equipment emissions, meaning all equipments, workplace, data center, network. All equipments that that touch to the process, to the project, or to the service needs to be integrated. And we will start by their manufacturing, that is important, their energy consumptions and the emissions related to that, and the end of life. And at the end, we have a full emission factor for this equipment. Then we have services, like software, cloud, or telecom. Sometimes we may think this is not important, and for some projects, it may not be that important because there's not a lot. But we need to remember that software, cloud, and telecommunications do have an impact. Even if we don't see it and we don't have it next to us, there's some equipments that make them work, there's some people, and there's a lot of resources that are dedicated to them. Here, in the first one, I show a bottom-up approach, meaning we go and see the equipments. In services, you can see that I'm going from the total emissions of the company and dividing it by the revenue. This is the less correct approach, let's say, it's our last resource. But it's what is available because companies are not that transparent. But there are some other things we can do to actually measure the impact of this kind of services. And it's what I will show you later with the impact of AI. But let's say right now, the easiest way to do it is to take this top-down approach. And finally, we have the teams. And sometimes we forget this. But there's always people working for these services. There's always someone. And I'm not only talking about maintenance or technical teams, but also HR, commercial, sales. Everyone has a contribution and everyone has a laptop. Everyone uses the company resources, etc. The percentage can be different. Maybe in some projects, equipment will take the biggest part and it will be focused only in energy. In some countries, it will be the case. In France, manufacturing takes more importance because the energy is decarbonated. It also depends on what are you studying, and it can change. It depends a lot on perspective. But so, this is a general approach for the environmental impact of IT. How can we apply to AI? Because now we hear a lot of AI. We heard that data centers are exploring their energy consumption. But the reality is AI exists since a long time ago. And so data centers have been consuming this energy since some years back. So we need to understand, first of all, what are the impacts in AI services. And I will get to GenAI, but first of all, let's talk in general. First of all, we need the training data, meaning that we need to get that data from somewhere and it to be stored somewhere else. Then we have the training, the development of actually the AI model. The same, we will have people, we will have equipment, and we have energy consumption. Then we have the use, the inference, the web hosting, the network, and the end user. We will agree that not all the little squares that I show you have the same impact. There will be a square that is more important than another one. For example, web hosting is not that impactful if you see the whole impact of the service. But if you are the one working on web hosting, you want to know what you can do. So, as I say, it always depends on perspective. But how can we measure this? Well, if we take the approach I mentioned before, we need the equipments, we need the services, and we need the people. But this is really easy if you develop everything complete on your own, because you will have the bottom-up approach. You know all the infrastructure, so you can count it in. Because you do the training, you do the AI development, and you can see maybe you don't have everything, but you can see a lot of the use. But this is an ideal situation, because actually today, even if you develop everything, maybe your infrastructure is with a provider, so you don't have the control of the equipment. Or maybe you only work in this, or maybe you only bought a service. So how can you know what's the impact? Well, the first approach is bottom-up, and it's, I will say, is the one with less uncertainties. Why? Because you have actual control of everything. But then, what we do when we want to just buy and use one AI service, there are other mixed approach, let's say, where, okay, I bought a model, I want to develop more things, so there's a part of the infrastructure I know and I control, and there's a part that I don't know. And here we arrive to a mixed approach between bottom-up and top-down. Because you can count your infrastructure, but you need to do some hypotheses about the things you don't control. So finally, we get to top-down. And actually, when we use ChatGPT, we don't, ChatGPT, sorry, in English. We don't actually control what is behind it. We only send a message, we have a response, and we don't know how many machines are working, how many parameters were used to build it, where the training data came from. Sometimes we know for some models, but sometimes we don't. And they try to keep it a secret. Later, Damien will talk about that too. But here, what we can do. There are some works of really smart people that starting proposing some alternatives to measure this. For example, there's an interesting work of ecologists, and what they do is they, simplifying, they try to understand how many energy it takes to process one token according to the parameters where the AI model was developed. Why we focus on that? Because if we see all this supply chain, if we can, all these phases, let's say, we will say that inference has the higher impact, because it's what is processing. It's always dynamic, while training and the development will have a static duration. We will say, okay, the data collection took this time and is this amount of data only. Later, the development, the training is also a specific time. But the usage of the model and the lifetime of the model, it will depend on a lot of things, and we cannot control it. So we don't know actually how can we control it. And it's here where we need to go a bit further to get to know what's the equipment behind, what's the energy consumption behind. Problem is the same problem we have in all IT services. Providers are not transparent. Even for the cloud, cloud has been a recurring issue like for years, and still we are not able, even with some calculators, to trust the providers about their footprint. So it becomes an issue, and here we are trying to do hypotheses to guess what is behind. And there are some providers that take it really, really seriously. An example of Scaleway recently is your work with Scaleway to develop their calculator. And it took an approach of really going for all the stages I showed before, equipment, services, teams, etc. But it's not the case for all providers. And for now, it's what we have. We don't have more. Even if we ask questions, we know they don't want to answer us. So we are limited to do hypotheses and to try to guess. But even though it's hard, there's a lot of people, and the ecosystem is gaining maturity. And we are starting to understand that impact here can depend on the use, but you need to see how you are using the models, and also that depending on the parameters, you don't need all that data, all that training to have an efficient model. And then I will let Damien explain more about that.
Thank you, Lorena. So when it comes to calculation, as Lorena said, it might need and might require some effort on your side to make sure that you end up with a figure that is a trustworthy figure that you can disclose to your customers, especially if you want to display what is the CO2 footprint of your product sometimes. If you don't want to calculate, but still you want to make sure that you have a reasonable use of AI, it's important to understand the full life cycle of the from the training to the inference, but also what are the real trigger that has a key impact on the CO2 consumption in the end. So if we look at the data set, there are different ways to process the annotation, the data cleaning, the anonymization. In terms of training and evaluation, actually, it's where you will make all the structuring choices for the following of your model. So, of course, you will make a decision related to number of parameters, whether you want a dense model or a sparse mixture of experts, whether you want it to be only text-to-text or maybe text-to-speech, text-to-image, and so on. Well, many parameters and many decisions to be made, and all of them will have an impact in the end on your CO2 footprint. In case you use the model and you want to fine-tune it, you also have a few triggers you can play with. And finally, when you set it up and make it run and serve in inference, you also have a few decisions to be made. Okay, good. So which model should I choose now? Well, let's distinguish first whether you will use a proprietary model or an open source model. If you use a proprietary model, actually, you do not have the end neither on this phase, this phase, this phase, on this one, meaning that you will be just a consumer. That's it. So as a consumer, you will have to make the best choice when it comes to the balance between performance and CO2. But what do you know about all these triggers? Well, you don't know much. And what is black here is what has, of course, been decided and made by the model producer like OpenAI, Google, and so on, but they have not disclosed this information. So you don't know how they did it. What is in orange is either public information or information that has been that has leaked on the internet, maybe, or maybe sometimes through interviews they disclosed a few pieces of this information, like the number of parameters, whether it's a dense or a sparse mixture of expert model, and whether it's, of course, a text-to-text or multi-modalities model. So you may know some of them, the rest you don't. Fine-tuning, well, if you use OpenAI, you can fine-tune your model with OpenAI, but it's an API, and you don't have your hand on the parameters of the fine-tuning. And finally, inference, again, you don't know almost anything except a feature that has recently been released, which is the caching. And when you use caching, actually, you reduce a lot your carbon footprint. So not so many items you can play with because you don't have many information. When it comes to open source, it's totally different. First, because, again, it's more transparent, open source, and even if you may use is when we fine-tune model, 10%, 6%, 6% in terms of scoring, so it's not that bad. And what we know as well is that the same model, fine-tuned or not, will consume the exact same amount of CO2. The fine-tuning phase will consume CO2, but it's a limited amount of time, and by that time, as inference model, it will not consume more. So for the same amount of CO2, you can have much better performance. Last example, if you run your own inference, there is a key trigger, which is a quantization. If, let's talk about Gemma 7b, if it's quantized with bits and bytes in 8 bits, which is quite a standard, you will have a 64 score. Unfortunately, we don't have a measure on Hugging Face for that, but we imagine that the score would be very slightly decreased, like 62 or maybe 61. But the carbon savings here, and it's really a savings, is huge because we save more than 30% of CO2 because we generate more tokens for the same with the same scoring of performance. Same here. And it's even better with another technique of quantization, the AWQ 4-bit. We can generate more than 300,000 tokens with almost the same level of performance. So quantization is absolutely key if you run your own inference, and that's a good manner to make sure that you will not consume so much amount of CO2. Finally, if you don't use open source model, but maybe proprietary model, there is also a simple way to reduce your carbon footprint is to use the distillation, because the distillation is a manner to get the almost same performance than the very, very large language model, but with a smaller model. And that has been released by OpenAI recently, for example, with the O1. And from the O1, you can go to the GPT-4o Mini, which is like 30 times cheaper. I don't know whether we can make an immediate link with the cost, but it's likely that in terms of carbon, you may also consume 30 times less. So for the same level of performance, you can have really good results. Time is running. So just to finish, a few resources that may be important if you want to dig into this topic. First, when it comes to measure, Ecologits, as Lorena said, is a very good repo to recalculate your carbon impact thanks to linear regression and existing measure. MLO2 is also a good repo. On Hugging Face, that's the repo I've used to produce the scoring. The leaks I was talking about when it comes to proprietary model, you will find a few characteristics at lifearchitect.ai/models. And finally, we've got dedicated measuring tool, EcoLLM, which is a French startup that has started really focusing on that. Boas Vista, I'm sure many of you know about the power measure sharing repo. This one is a tool, and very smart tool, because it's a kind of routing tool, meaning that when you start writing a query, this tool will actually say, okay, depending on your query, I think that it's better to go to Mistral 7b, or maybe you should go to Llama 3.1 7b, which is, of course, better, but maybe more expensive and more carbon. And finally, quantization techniques and tools, that's huge impact, but also interesting repo to be used if you want to go further. And everything I said, to finish, is a trade-off of performance and carbon impact and cost. But measuring the performance is also something very complicated. So there are many evaluation frameworks when it comes to performance. I've listed a few of them. The most famous one is the one produced by Hugging Face, but here you've got something that is maybe more adapted to enterprise. And finally, we've got dedicated framework for coding, for example, and so on. We are done. Thank you very much. I'm happy to.
We have time for some questions? Two questions, okay.
2 minutes. Okay.
So you mentioned that the more you have your hand on the infrastructure, on the configurations, the more open source the model is, the more chances you have of improving the performance. But can we consider that only a small portion of users are actually going to use these open source models to improve the environmental impact, and that on average, the users of these more open models are actually going to have more parameters and probably like a worse environmental impact than if they were using like a standard model where they don't have their hand on these additional config.
Yes, it depends, because the issue is that also as users, if we want to do something, we don't have the money to create, even the money to create something big and as efficient as the big providers. And here we're seeing also that providers will do stuff that we don't need. They will go too far, even though with less you can have the same performance. So the idea is to put pressure on the providers to say you need to be more transparent and you need to make available these for the users at the real I mean, cost, but not in money, but the real cost for the environment. And let us understand what is our impact so we can control it and make more efficient decisions about it. But it's complicated because science, they are not transparent and we are trying to do something different. Yes, it's a conflict.
The big providers, they have a responsibility because indeed, it's so easy to go always to GPT-4o from OpenAI. It will work, yes. But in the end, especially for you guys, I imagine that many of you are product managers. If you want to create the best product with the best choices, maybe GPT-4o is not the easiest way to go. And maybe there are other ways, more reasonable ways to do. So I'm sure that this is valid for you, but your question was also, what about the mass? And about the mass, of course, we don't control that. That's why I said that the OpenAI, Google, and maybe other big providers, they have a responsibility. Producing always a bigger model and so on. Okay, but until when?
Thank
you very much.